Hello, AP Environmental Science students. This set of notes will focus on natural ecosystem disruptions. Some essential knowledge. Natural disruptions to an ecosystem have environmental consequences that may, for a given occurrence, be as great as or greater than many human-made disruptions. Um, Earth systems processes operate on a range of timescales. Processes can be periodic, episodic, or random. The Earth's climate has changed over geological time for many reasons. Sea level has varied significantly as a result of changes in the amount of glacial ice on the Earth over geological time. Major environmental changes or upheaval commonly result in changes in large swaths, of habitat changes. Wildlife engages in both short and long-term migration for a variety of reasons, including natural disruptions. Okay, with that out of the way, so like it says, the environment is changing all the time, and that change can be because of a myriad of different things. But we kind of use three different categories to put them in. So one can be random change. So an example for that can be continental drift. It's not set where that's going to happen, but it slowly changes things over time, but it's fairly random. Periodic changes, so these are like shifts in solar output or the Earth's orbit. Don't know what that was, but these are things that we know. So, like for example, the Earth's tilt, we know when that's going to change. We know when the orbit is going to change and where it's going to be at. So we can predict those things. And then episodic changes, these are things like supervolcanoes, asteroid impacts, coal fires. It's like big, out of the ordinary events. That's what you can think of them as. And we'll go through these one by one a little bit more in depth. So, with this, and just the big thing is understanding how our ecosystems change in concert or in line with climate changes. And remember, like the difference between climate and weather. So climate is this bigger thing on a much larger scale than things like weather. Weather is a local area, what's happening in that exact place and exact time. Climate is what's happening over months and years. So scientists can directly measure ancient climate conditions, so it's not like we're just guessing what's going on. In fact, there's been accurate temperature measurements that began in the 1880s, and accurate atmospheric measurements that began, in 1958. This does not mean that this was the only time that these were around. We can use these different methods that we're going to talk about to go way, way, way back in the past, to kind of build the bigger picture of what's going on with the climate. So the study of the ancient climate has its own thing, and that's paleoclimatography, and for this process and for this science, they rely on proxies. So these are different things that they can measure to, like I said, put those puzzle pieces together to tell us what the climate was like at a certain point in time. An analogy that's used in the example here is, so say studying old newspapers to learn about crime statistics. So you can take something that's from the past, read it, see what's going on with it, so that'd be our proxy, and then be able to figure out or understand what something was like in the past. So in this case, it'd be things like crime statistics, or it could be like the amount of people that sunk in the Titanic. So there's different levels, and so we have short term, medium term, and long term, and we're going to go through all of those with reading the past. For short term, one of them is tree rings. So we can use old living trees and preserve dead trees that we have, and we can look at their rings. And these rings, contrary to what everyone wants to tell you, of like you can tell how old the tree is, or really that's not what we're looking at. What we're looking at is the growth between those rings. So trees will grow faster when it's warm weather, so you'll have a wider dispersion between one ring to the next, and slower when it's cold, weather. So the lines will be really, really, really close together. And the reason why, like the whole age thing, it depends on the different types of trees. Some trees will add several rings in a year, so it's not accurate. Just FYI. Medium term, so this can be things like ancient pollen. So pollen is always being blown around. If you're an allergy sufferer, you know how it is. But what happens is the pollen will get blown around, then it will sink in water, and it will become like a layer in the bottom of the lake or something like that. And with that layer, we look at the different pollen and what type of plants they're from, and that will tell us what the climate was. So if it's from mostly warm weather plants, we can assume that it was a warm weather climate. If it's cold weather plants, cold weather climate. And this is something that they do off of like Lake Superior. They'll take a boat and they'll take samples of the layers on the lake floor and then use a microscope to look at those different types of pollen and figure out what's going on. And then long term is we have ice cores. So these is just atmospheric pressure or atmospheric gas, that's trapped in bubbles in our ancient ice. So they take this from like Antarctica and different places around the world. And what they'll look at is the amount of CO2 in those bubbles, because the amount or that ratio of CO2 and our different isotopes in there can indicate what the temperature was. So we can have kind of a direct correlation with those numbers to figure out what's going on. And with this process, and one of the reasons why it's long-term is because they can go back approximately 800,000 years. So just a little bit far back. Yeah. So here's some graphs. So we can look at it in different terms. So we can like look at this graph and say, okay, what was it like in the medieval times to now? So something that seems like a really long time to us, but that's because we're humans. Remember, we're talking about a geological time scale. Or something like this, where we can be looking at several thousand years. So this is pretty much going back to 0 AD to current and what's going on with temperature. And then we can look at hundreds of thousands of years, so that long-term stuff. So this would be things like what the temperature was like in our ice cores. Yeah. So as our climate changes, we see a bunch of different things happen. What I'm going to do is I'm going to pop out real quick, and I want to show you all. So NASA has this cool thing, the Climate Time Machine, and this will be posted. I'll post a link to it in the support. But you can look at how things have changed over time. So if I click on something like, we'll pick sea levels just for this example. And so this shows the southeastern United States, and it's showing how the land would be different if the ocean rose, well, from 0 to 6 meters. So if I go to like 1 meter, so if the ocean was 1 meter higher, things like New Orleans would be in jeopardy. Parts of Florida would start to get encroached upon. So this would be places where the ocean is now, well, where the ocean isn't right now, but would be if it rose a meter. So if I zoom all the way to the end, we can see how if it was 6 meters, Miami's pretty much gone. It's underwater. Same with New Orleans, and a lot of the eastern seaboard and some of the southern in the Gulf. But this is a really cool thing. You can pop around to different places. It also has carbon dioxide, global temperatures, and sea level. So I implore you, please check this out. And in fact, that's one of the things I want you to check it out and just tell me what you thought. Which one did you look at? And what did you find interesting? Back to this. So the final thing is, what does this all mean? Well, the big thing and the big thing that we want to focus on is, well, how do living things respond to this? Because if the climate's changing, hopefully things are going to change along with it. So organisms, animals, things like that, plants are going to migrate. They're going to adapt or just disappear. Those are kind of the three things that they could do. So animals can migrate quickly as individuals. They can fly down south. If you think about like the Canadian geese moving south, but plants, they migrate really slowly as a species. They rely on things like wind or different types of seed dispersal. So birds are eating them and dropping them somewhere else, or things like the stickers So like burrs that get stuck onto your clothes or animals' fur, and then will be transferred somewhere else, but a relatively slow process. And the ecosystem is going to respond depending on its biodiversity. So depending on that biodiversity, it's going to tell, well, how resistant is this? And we talked about this before, its ability to avoid that disruption, and how resilient it is. So is it going to be able to recover from that disruption? But that does it for this set of notes. In our next set of notes, we're going to talk about those disruptions and what's going on with them and how they respond. So see you then. Bye.